Good morning, Mar. Last class we have studied the basics of PLL. So what is actually PLL? PLL is a frequency selective circuit which is synchronized with the incoming signals. Okay. Basically, a PLL consisting of a phase detector, loop filter, and a voltage controlled oscillator and an amplifier. The phase detector compares the input signal frequency and the output of the voltage controller, the oscillator, and produces just like a mixer with some frequencies, different frequencies, and that is some frequencies means omega 0 plus omega I, different frequency becomes omega 0 minus omega I. But unlike a mixer or multiplier, this phase detector output usually the difference frequency is a DC voltage. DC means you are having 0 hertz frequency. In other words, the omega I should be equal to omega 0. And all these frequencies, the output of this phase detector is passed through a loop filter, which give out only the difference frequency out. So usually a DC voltage is coming out and the amplifier amplifies this DC signal and given to the voltage control oscillator. So what is a voltage control oscillator? It's just like an oscillator. But here for VCO, we are having some DC input, unlike other oscillators. So VCO frequency free, if there is no input for the VCO, it will oscillate at free running frequency omega 0. Uh, if there is an input voltage, according to the polarity and amplitude of the input voltage, the VCO oscillate at some other frequencies other than omega 0. The purpose of the PCL is to usually at the receiving system, the incoming signals are immersed in noises and there are a lot of disturbances along with these incoming signals. So the purpose of the PLL is to clean up these incoming wanted frequencies and attenuate, highly attenuate the noises and other disturbances. PLL 565, the functional block diagram. Here, it consisting of is the internal is detector, amplifier, and for the low pass filter, only the resistor is internally fabricated, while we have to connect the external capacitor for the lead. And for also for the VCO, we have to connect the R1 C1 combination external, so that by varying this R1 C1 value, actually we can vary the free running frequency omega 0. And the output of VCO is a square wave, unlike sine wave. So what is the difference between a square wave and a sine wave? A 1 kilohertz sine wave consisting of pure sine wave, while in the case of a square wave, 1 kilohertz square wave means it's consisting of 1 kilohertz fundamental sine wave as well as its higher harmonic. So 1 kilohertz means 2 kilohertz, 3 kilohertz, 4 kilohertz, so on. It is consisting of the sine waves. higher harmonic cycles. But as the number of harmonic increases, the amplitude of it decreases. As I told you earlier, the PLL goes through three stages. The first one is free running stage, capture range, and third one locked or tracking range. Free running means the input coming frequency is very far away from that of VCO free running frequency, so that the PLL is not able to catch the input frequencies and vary according to the input frequencies. So at this stage, the PLL oscillate at free running frequency, or VCO output is free running frequency. The second stage is capture range, the range of frequencies over which the PLL can mainly talk with the incoming signals. When the indicator shows the characteristics of PLL, this is the free running frequency. The output DC voltage is equal to control voltage, output of the amplifier, the input of the VCO at this frequency is equal to 0. So when the incoming frequency is between F0 minus delta Fc and F0 plus delta Fc, the PLL is able to catch the incoming frequency. That's capture range. So once it captured or when it locked with the input frequency, even if when the input frequency increases or decreases, then the capture range. That is one of the capture range. The VCO can follow the incoming input frequency variations. So this is the log range, F0 minus delta F2, F0 plus delta F. Usually, log range is more than capture range. PLL 565 having for the phase detector we are having three inputs, one input for the incoming signal frequency, one input for VCO. Indeed, we need to connect some other external input. Of course, we can use this pin also. And since VCO out fourth pin, so you have to connect externally from VCO out to phase comparator. So also have to connect external R1 C1 combination and also this C2 combination for low pass filter. You can take the demodulated output from here. So here shows the capture range and lock range of the PLL. Next part is applications of PLL. There are so many applications for PLL. Usually for the PLL, we take two types of output, either the error voltage V of t, that is output of the amplifier or input of the VCO, and second output is the frequency signal of VCO output. The voltage output is used in frequency discriminator applications, while frequency signal output is used in signal conditioning, frequency synthesis, and clock recovery applications. Voltage output in frequency discriminator means for the demodulation of F1, usually this PLL circuit As you know, what is FM? The amplitude of the information signal. According to the amplitude of the information signal, the frequency of the carrier wave is varied, then it is called a frequency modulated signal. So I think receiver side, you have to note, we have to note down the variations of the FM signal from the carrier frequency and has of the information signal. So PLL is the best option for demodulated FM signal. And if you're considering the frequency output of the VCO, usually the input frequency is comprises of many frequency components corrupted with the noise and other disturbances. So the PLL can be made to know only one frequency component of the input. The output of the VCO can be made to regenerate that particular frequency while alternate heavily other components. Thus, VCO output can be used to recondition or regenerate a desired frequency signal which is weak and buried in noise. So, we are only selecting a particular frequency, that is our wanted frequency, from the group of incoming frequencies and regenerate or recondition the wanted frequency plus frequencies while attaining all other frequency components like noise and disturbance. The first application is, there are a lot of applications for PLL, as I told you earlier, like frequency multiplier, frequency translator, FM demodulation, AM demodulation, FSA demodulator, frequency synthesizer, etc. So we are discussing four applications here. The first one is frequency multiplier by using a PLL. What is a multiplier? Frequency multiplier means whatever be the incoming frequency, it is multiplied by a factor. Suppose if your incoming frequency is 2 kilohertz, if it is multiplied by a factor 10, then you have to get 20 kilohertz out. So whatever be the information, it is this 1 kilohertz, 2 kilohertz must be transferred to this 20 kilohertz. So here we are using an external divide by n network which is equivalent to a frequency counter. So the output of the VCO is given to the square wave, is given to the frequency counter and it is divided by n and is given to the phase comparator. So phase comparator compares the input signal and the divide by n signal so that it produces an error voltage here, so that after some time it will be able to log with the divide by signal and signal. So what is F naught? F naught is equal to, or F naught by n is equal to Fs. So what is F naught? F naught is n times Fs. This is the output will act as a multiplying factor into the incoming signal. The same circuit can be used for frequency divider also. For that, we have to select higher harmonic of the incoming signal frequency at the output of VCO. As I told you earlier, the output of VCO is a wave, so it will be, it's rich in harmonics, so that you can select a higher harmonic, let it be M, Fs. So Fs is F naught is equal to mFs. Fs is equal to mF naught by n if you are using a divider network. Of course, you can select this m and n so that you need have a multiplication factor like m by n. So this can be used as a divider or this can be used as a multiplier. Of course, if the input is rich in harmonic, VCO can be directly locked to the nth harmonic of the input signal without connecting any counter in between. Harmonics of course, you can tune the VCO to a harmonic nth harmonic of the input signal. The same block diagram of the frequency multiplier can be used for frequency division also. The VCO output is a square wave, which means that it contains many higher order harmonics. Therefore, it is possible to log the nth harmonic of VCO output with the input signal F. The output of the VCO is then given by F out by F is equal to F in by N. The next application of PLL is frequency translator. What do you mean by frequency translator? If the incoming frequency is signal frequency is Fs, we are transferring the information of Fs to some other frequency. It's not much if greater than us. Some say Fs plus F1. Okay. That means transferring all the information to some other frequency. As you know, in AM modulation and demodulation, actually whatever be the incoming signal frequency, after 1 or 2 stages, transferring all information to a intermediate frequency, let it be 55 kilohertz. Similarly, we can transfer the information to some other frequencies. Here, the external circuitry consisting of multiplier and a low pass filter. The VCO signal is called to the multiplier. So the multiplier so the output of the multiplier consisting of consisting of hello. 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 So the output of the multiplier consisting of some frequencies, that is F5 plus F0, and its frequency is F1 minus F0. So the NPF, the output of the low pass filter consisting only the difference frequency F0 minus Fs. So this is given to the phase comparator. F0 minus Fs, the input from outside, that is offset frequency of one. So the difference of the phase. The output of is not equal to F plus translator. The schematic of shifting the frequency small factor multiplier externally the signal Fs and the output of VCO F are applied to the mixer. Mixer output consists not minus Fs and another input of phase detector is adjusted to make these two inputs. This phase shift is 90 degree because input signal is passed through PL. It undergoes a phase shift of 90 degree. So in order to make both the phase same, we are passing